Hi, and welcome to my video on transformations on ordered pairs. And again, this is a practice one, a review of transformations on ordered pairs. Number one, find the value of each image. We have a mapping rule here, which says x comma y is mapped to x plus 2 and 2y. So x plus 2 is 6 plus 2, so that's 8. And 2 times y is 2 times negative 4 is negative 8. And the mapping rule here is x comma y is mapped to negative x, 3y minus 1. So x goes to negative x, negative of negative 5 is plus 5. And 3 times y minus 1. So 3 times 2 is 6, minus 1 is 5. So this is obeying the mapping rule. Number two, the mapping rule is x comma y is mapped to x minus 1, y plus 4. Map the table of values. So we have x going to x minus 1. So we take 1 off of 2, take 1 off of 1, subtract 1, subtract 1. And the y is increased by 4. So 2 plus 4 is 6, 1 plus 4 is 5. 0 plus 4 is 4. Negative 1 plus 4 is 3. So that's using a mapping rule on a table of values. Number three, the horizontal reflection. When you reflect horizontally, it's reflected in the y-axis. So horizontally is this way, so we reflect in the y-axis. And when you reflect in the y-axis, what happens is that the ordered pair is that the x is changing. So x, the mapping rule for x comma y in a horizontal reflection, so you get the negative of x, but the y doesn't change. So to practice that, to do the map horizontal reflection on this ordered pair, we change x negative 2 to a 2, and we don't change the y. So negative 2, 3, negative 2, 3 is right here. And that goes reflected across over here to 2, 3. And 1, negative 1. So the point 1, negative 1 is here. So when you reflect in the horizontal reflection, reflect in the y-axis, you change 1 to a negative 1, but you don't change the y. So you reflect across, it goes right here. So it goes to right there. So it moved right there. And this one up here moved to right there. So you can see when you reflect horizontally, you change the x but not the y. A vertical reflection is, so vertical is when you reflect up and down. So when you reflect vertically, you reflect in the x-axis. And the mapping for that is when you do vertical, you don't change the x, so the x stays the same when you go from here to here, but you change the y. So when you reflect vertically, you change the y. When you reflect horizontally, you change the x. Horizontally is across the x is changing. Vertically is across. When you change vertically, you go across the x, so you change the y. So if you have, again, vertical reflection, you don't change the x, so negative 1, 2. So x is negative 1, 2. That's right there. So when you reflect vertically, you're going to negative 1, negative 2. So the x stays the same, but the y changes. So that's going from there, reflect down to there. That's right. And 3, x is 3, y is 1. That's right here. So when you reflect vertically, you move across here, you go to here. So reflect. So the 3 doesn't change, but the y does. Okay, so again, a horizontal reflection is you reflect in the y. You change the x. A vertical reflection is up and down. You reflect in the x-axis and you're changing the y value. Another type of translation is the horizontal stretch. And the horizontal stretch is stretching the value of the x. So the mapping rule on the horizontal is what we call AX, but we're not changing the y. So the horizontal stretch, you're multiplying the x value by a certain number. So x comma y goes to 3xy. So 3 times 2 is 6, but you're not changing the y. Horizontal stretch is multiplying the x value by whatever it is in front. So here it's a 3. A vertical stretch is stretching the y value, so it's an x going to, we say, b times y. So with the x is an a, with the y as a b. So again, x comma y is x. So x is x, so that's a 6. But the stretch here is a 2. So the y value is stretched by 2, so 2 times 7 is 14. A horizontal translation. Translation means moving it left to right, sliding it left to right. Horizontally is going left and right, so it's affecting the x. So it's x plus or minus h, and the y is not changed. So it's a plus h or a minus h. So x plus h. So we have x plus 3. So we take the negative 2 and we add 3, we get a 1. So we're moving it 2, we're moving it 3 units right. So negative 2 add on 3 is 1, and the y is not changed. We're just moving the point to the right 3 places. And here, we're x comma y is going to x minus 7y. Again, the y is not changed. The y value, when you go horizontally, the y stays the same as the x that moves. So if you're at 8 and you subtract 7, you go 1. So x from x to x minus 7 means you're moving it 7 units left. So horizontally is left and right. So this is right 3, this is left 7. C, x comma y is x plus 4 comma y. So notice it's horizontal. You're adding 4 to the x. So you're moving the point right. So you're moving the point right 4 units. And you're not changing, not moving it up or down, because you're not affecting the y. And here, you're going from x to negative 6. So you're moving the point left 6 units. So a positive 4 is moving it right 4 units. A minus 6 is moving it left. So whatever this value is, you're taking off 6. Whatever this value is, you're adding 4. So adding 4 to the x coordinate, moving it right. Subtracting 6 is moving it left 6. State the mapping for the horizontal translation. So here, the mapping for the horizontal translation. So 4, 8, horizontal is not changing the y at all. So here, it's 4 to 1. So when you go from a 4 to a 1, that's moving it left 3 units. And right here, horizontal translation, again, horizontal translation is affecting the x. So you're going from a negative 2 to a 3. So that's 5 units to the right. So it's a plus 5. So if we take a negative 2 and add on 5, you get a 3. If you take 4 and subtract 3, you get a 1. So this point is moving 3 units to the left. This point is moving to this point. It's 5 units to the right. Okay, let's continue. Just a review of the transformation on ordered pairs, which you will see again and again when we look at other functions in relation to lines, parabolas, etc., circles, ellipses, etc. What about a vertical translation? Well, a horizontal translation moves it left and right. A vertical translation moves up and down. So the mapping rule is a vertical translation is not affecting the x, but it is affecting the y. So what we do is with the x is a plus or minus h. With the y, we agree, and books agree, teachers agree, is a plus or minus k. So what we have here, if we have x, y is mapped to x and y plus 14, so x is not changing, and we're adding 14 to the y, so that's a 12. Negative 2 plus 14 is 12. So that means negative 2 to a 12 is 14 right. So this ordered pair has got 14 right. Sorry, 14 up. My mistake. Because it's the y plus on the y, it's up. So negative 2 is going up to 12. The x is not changing. And right here, the x is staying the same, so that's a negative 3. And y to y minus 6 is going down 6. So 1 subtract 6 is negative 5. So the ordered pair is going down 6 units. So 1 goes down to negative 5. The x don't change. C, we got x comma y and x to y minus 3. So the x is not changing. So this is moving the point. Again, is affecting the y. So it's up or down. The negative is down. So it's going down 3 units. And here, the ordered pair is on the y. So it's plus 2. So it's going to y plus 2. So no matter what y is adding on to. So this initial point, whatever it is going up 2 units. So when you affect the y, it goes up and down. Positive up, negative down. When you affect the x, it goes left and right. Positive is right, negative is left. State the mapping rule for the vertical translation here. So vertical translation is affecting the y. So x is not changed. So the y is going from a 2 to a 6. So it's a y plus 4. 2 plus 4 is 6. And right here, again, is the vertical translation. Negative 1 is not changed. So it's the x. And this is going from a negative 4 to a negative 9. So this is a y minus 5. Negative 4 to a negative 9 is a minus 5. So that's a y minus 5. It's going to the left 5. Number 9. Translate and plot this ordered pair of 2, negative 4, using each translation in a sequence. The mapping rule on, state the mapping rule on 2, negative 4 to obtain the final point. That's the mapping rule I'm going to have down here. So let's take this point, which is 2. X is 2, negative 4. X is 2, negative 4. Let's take this point right here. Okay. And let's take, I forgot to change this. This is a 2 here. So that's a 2. So this is the point. I forgot to change that. This is the point we're going to reflect. So we're taking this point. Oh, I forgot. I made changes and I forgot to change it. So this is the point 2, negative 4. So point A is the 2, negative 4 reflected in the y-axis. So we're going to take this point and reflect it in the y-axis. So we take this point and reflect it in the y-axis. That means we will go to reflected in the y. So we'll go here. Reflected in the y is right across here. So that's A. So there's the point. 2, 4. So this is the point 2, negative 4 here. So reflecting it into y will go. There's the mirror image. Now we're going to take A. Point B is point A, a horizontal stretch of 3. horizontal stretch is this point right here. I just want to name this point is -2, -4. So we're doing a horizontal stretch, so that's stretching the x value. So a 3, so this point is we're stretching the x value 3 units. So there's a -6 and -4. So -6, there it is there. There it is. Now, point C is, this is B. So we're taking B and doing a horizontal translation of 1 left. So we're taking B and moving it 1 left. So B goes right there. So that's point C. So this point is -7, -4. 1 unit left, -7, -4. Then we're taking C. Point D is point C reflected in the X. So you take point C and reflect it in the X. So that's -7 and reflected in the X. The X won't change. So it's a -7, which is, that's a 6. So X is -7 right there. And you move up. It's -7. And that's a -4. So when you move up here, you go up to 4. There it is there. That's not the point right here. There it is there. So it's reflecting. So when you reflect right here, there it is, right across, right there. So this point, X is -7, so the X is not changing, but reflect in the X, the Y value changes. So that's the point that we have. So when we do all this reflection on that point, you come up with -7, 4. That's what D is in the end. And if that's D in the end, then what do we have? Well, we have a horizontal reflected in the Y. So when you reflect in the Y, you're changing the X. So it's negative on the X. So when you make X negative, you're reflecting in the Y. You got a horizontal stretch of 3. So that's 3 times X. And a horizontal translation of a -1. So it's the X is a -1. And reflect in the X-axis, you're changing the Y value. So there's the mapping rule that reflects. So I moved it. There it is moving, picking up these points. So if you take this point, so if you take the point 2, -4, and sub in here, you should have these coordinates. Take a 2 and put it here. -3 times 2 is -6. Subtract 1, -7. And you take the -4. So that's the negative. Y is -4. The negative of a -4 is the +4. So that's the right wrapping rule. This is the right point that you end up with. Again, just be careful. It takes a while to practice that, but students find that a little bit confusing. And to end it off, we just end off with state the order of the transmission. The order that I always do is that I reflect, I stretch, and I translate. Reflect, stretch, and translate. You always do the reflections first, on the reflect on the X, reflect on the Y. Then you stretch it, so you got a horizontal stretch and a vertical stretch, and then you translate it left, right, up, and down. Reflect, RST, alphabetically. Reflect, stretch, and translate. As a result, reflect, this is that negative, is reflect. So that's when you reflect in the, when you make X negative, you reflect in the Y axis. When you have a negative here, you reflect a negative on the Y, you reflect in the X axis. So a negative with the X, you're changing the x value to the opposite, so reflecting the y. So when you change the negative on the y, you reflect in the x-axis. So changing the x, it reflects in the y's. Horizontal reflection. Negative on the x is horizontal. Negative on the y is a vertical. And vertical reflecting the x, horizontal reflecting the y. It just takes a while to get used to it. A is a horizontal. I'm going to say H for horizontal. A horizontal stretch. And the B here is a vertical stretch. So the number in front of the x, if there is other than 1, it's a stretch. So this is affecting the x as a horizontal stretch, and affecting the y is a vertical stretch. And the plus minus, this is a horizontal translation. So plus is going horizontally to the right, and negative here is going to the left. And this k plus or minus is a vertical translation. So again, the plus minus with the x is horizontal. Plus is right, negative is left. This number in terms of the y is a vertical translation. Plus is up, minus is down. So based on that, let's see if you can comprehend. Hopefully I'm trying to make it better for you to understand. For each mapping rule state, so I got a mapping rule, so I'm going to go through all of these to see. So this mapping rule, is it reflected? This is not negative, and the answer is no. It's not reflected, no. A horizontal stretch, you got an 8. The horizontal stretch is 8. 8 times. The horizontal translation is, it's a negative 1, so it's 1 left. Is it reflected? Yes. Because it's a negative. Because it's negative. The vertical, that's a 1, so that's a no. And the vertical is a 1, so it's not stretched at all. The vertical translation, no number on the end here, is a no. So when there's a 1, there's no stretch. It's only when there's a 2 or a half, etc. So this one, again, we got a negative here, so it's reflected. The answer is yes, because the x is negative. And the horizontal stretch is no, because you only got a 1. And it's plus 2, so that's 2 plus, and the horizontal is 2 right. This is positive, so it's a no. Only if it's negative. And that's a vertical stretch of 4. Vertical stretch is 4. And we got a vertical translation of down, because it's negative. It's down 3. And one more. So here we have no negative, so it's no. We got a 1, so it's no. A horizontal stretch. And this is a minus 4, so it's a horizontal, so it's minus is left. And right here we have no negative, so it's a no. We have a 1, so it's no vertical stretch. And it's a plus 6, and the plus 6 means it's up 6. So if it's with the y, it's up and down. It was with the x, it's left and right. Now, here we go. Let's state the coordinates of this point. State the coordinates of the image of 2, negative 3 if reflected in the y. So if it's reflected in the y, that means reflect, think about it, reflect in the y-axis, so you're changing the x. So it's a negative 2, negative 3. Now, you're going to take this point and move it 1 right. So if you move it 1 right, you're affecting the x. So negative 2 plus 1 is negative 1. But you're not changing the y. A vertical stretch of 4. Vertical stretch of 4. So that's 4 times the y value. So it's a negative 1, negative 12. You're stretching the y value 4 times what it is. And it's up 5. Up means it's not affecting the x. So you go up 5 from negative 12, you will get a negative 7. So that's the coordinates of the image of that. If you stretch it, reflect it, 1 to the right, vertical stretch of 4, and up 5. So there it is there. That's the image. So I do one at a time, as you can see. So again, hopefully that helps you understand transformation, because a lot of students find it confusing and it takes a while to get used to it. Just trying to help you out, help you understand. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. I hope the video helped you. Bye-bye.